Hello, my dear students. Let me welcome you all to today's knowledge sharing session. In this video module, I am going to present in front of you the basic concepts, some formulae, some terms and terminologies related to the topic probability. So let's get started. I want you to consider a chemical reaction first. Let us consider sodium hydroxide. It's reacting with hydrochloric acid. Okay. So could you please tell me what is going to be the outcome of this experiment? Yes. Sodium hydroxide and hydrochloric acid, they react with each other. You know that the product, it will be sodium chloride and water. Wherever you are conducting this experiment, you know that this is definitely going to be the outcome, right? There is no confusion here. Now, on the other side, I am asking you to consider another experiment. I am asking you to roll a cubic dice. Okay, you roll a cubic dice. Now, my question is, listen carefully, what is going to be the outcome? You cannot answer me with 100% surety, right? When you are rolling a dice, you may end up seeing a 1 or a 2 or a 3 or a 4 or a 5 or a 6, right? Assuming that it's a fair dice, it's unbiased, and also it's a cubic dice. So when you are rolling it, you may end up seeing a 1 or a 2 or a 3 or a 4 or a 5 or a 6. But what is going to be the outcome if I'm going to ask you? You cannot say with surety that I am going to get 4 or I am going to get the number 2, right? You can't say it with certainty. But whereas sodium hydroxide and hydrochloric acid, this experiment, when we considered with certainty, you are able to tell me the product it is going to be sodium chloride and water. So these are two different types of experiments, I will say. Okay, so the experiments, I am categorizing them or classifying them into two types: deterministic experiments and random experiments. The first one that I presented in front of you, that is the sodium hydroxide. It is reacting with hydrochloric acid, giving you sodium chloride and water. This is a classic deterministic experiment. With certainty, you know what is going to be the outcome. Whereas a random experiment, something like tossing a coin, okay, assuming that it's an unbiased coin, tossing a coin, rolling a dice, etc. These types of experiments, I call them as random experiments. Okay, now, what is this trial all about? Suppose I am going to roll a dice. When I am doing it, I call it as a trial. Okay, tossing a coin. I'm just doing it now. Just imagine I'm doing it now. Then it's a trial. Okay, so trial means one such experiment when I'm performing it, I call it as a trial. Now, what is an event? The event, this is a specific subset of outcomes within the sample space. Okay, in that case, now I need to talk to you about what is this sample space. Sample space is nothing but the set of all possible outcomes of an experiment or a situation. Now I shall connect this sample space and this event. Okay, sample space is as such, I should say, it is reporting to the experiment. For example, when I am rolling a dice, the set of all possible outcomes, if I'm going to consider, I may end up seeing a 1 or a 2 or a 3 or a 4 or a 5 or a 6. Okay. So this set of all possible outcomes, I call it as the sample space. Sample space, it is reporting to the experiment that I am performing. Now, after defining the sample space, now the user or the person, he is defining an event. Okay. For example, I rolled a dice, the sample space, it is 1 or a 2 or a 3 or a 4 or a 5 or a 6. Now, I am defining an event. I am saying I end up seeing a multiple of 3. So, when I am defining it, I am defining that it's the event. The event is actually defined by the individual. The event, it is reporting to the individual. Whereas sample space, it is reporting to the experiment that is being conducted. This you have to understand very clearly. Okay. So the event which I am defining, it is, say, I end up seeing a multiple of 3. I end up seeing, say, multiple of 5. I end up seeing the number 9. So these are some of the events that I am defining. Okay. Now, when I am considering an event, what is the chance that that event it is going to happen? Okay. So probability, it actually tries to talk about the chance of occurrence of that event that I am defining. For example, what is the chance that I am going to see a multiple of 9 when I am rolling a dice? I say the chance, it is nil. It's not going to happen. Got my point? But what's the chance that when I'm rolling a dice, I'm going to see an even number or an odd number? I will say that it's 100%, 100% chance that it's going to happen. You got my point? So probability, basically, it talks to you about the chance of occurrence of an event. Now, let's talk more about probability part. Probability, what it actually does? It attempts to quantify the chance of occurrence of an event. Probability, it tries to express this chance part in numbers. Got it? Just like how your CGPA, in a way, it is quantifying your academic performance. In the same way, probability, it is trying to quantify the chance of occurrence of an event. And the classic definition, probability of a particular event, it is actually a ratio, I should say. It's calculated as the total number of favorable outcomes divided by the total number of outcomes. This total number of outcomes, what you see in the denominator, I can even say it is nothing but the number of elements that's there in the sample space, number of elements in the sample space. Okay, that is nothing but the total number of outcomes it's all about. So P of E is total number of favorable outcomes divided by total number of outcomes. Okay, now if I am considering this probability as a ratio P of E, please be aware that it's going to take values in between 0 to 1. Ratio wise, the range of values that P of E it can take 0 less than or equal to P of E less than or equal to 1. Okay. For example, like I told you, when I'm rolling a dice, what is the probability that I'm going to see a multiple of 9? I will say P of E it is equal to 0. So please note, if I say P of E, it is equal to 0, understand I am referring to something called as an impossible event. Okay. In the same way, I'm defining another event. When I'm rolling a dice, what is the probability that I'm going to see either an even number or an odd number? So in that case, I will say P of E, it is equal to 1. And I will say that it's 100% it's going to happen. I will say that it is a certain event. Okay, I can put it that way. Okay. Now, ratio-wise, the range of values, the P of E, it can take 0 less than or equal to P of E less than or equal to 1. It comes this way. Now, if I am going to consider percentage-wise, this P of E, the range of value possible, it is 0% to 100%. Okay. So, as you know, it's a ratio. If I say P of E, it is equal to 1 by 2. It's as good as saying there is a 50% chance that this event, it is going to happen. So like that, you are going to interpret it. If you are expressing it in percentage, then understand P of E will take values in between 0 to 100, both 0 and 100 included. Ratio wise, it's 0 to 1, both 0 and 1 included in that consideration. Got it? Probability value can never go negative. This probability value, it can never exceed 1 ratio wise when we are considering. Same wise, percentage wise when we are considering, it can never go negative and it can never exceed 100% also. It can go up to 100%. So please keep this in mind when you are attempting the problems. Okay. Now, what about the complement of an event? Let's talk about this. I'm giving an example here. Okay. Suppose weatherman says that there is an 80% chance that it is going to rain. Okay. On a particular day, the weatherman says that on that day, there is an 80% chance that it is going to rain. Okay. So what does that actually means? On the other side, I can consider that if probability that it is going to rain, it is 80%, there is a 20% chance that it is not going to rain. We won't say that there is a 20% chance that it is going to shine. Okay. There's a 20% chance that it is not going to rain. It may remain cloudy throughout, or it may remain fully humid, but it won't rain. What is the chance for that? That's what this 20% is. So 80% chance that it's going to rain, 20% chance that it's not going to rain. Like that, you will consider. Okay. Now, in the same way, the complement of an event, E, it is denoted as E bar, what you can say. Sometimes it's written as E to the power of C kind of thing, E raised to C, like that. Superscript, E superscript C. It's a set of all outcomes in the sample space that are not in E. This, I should say, the complement of an event, it is also considered as sometimes P of E bar. In this way also, I have seen notations. Okay, so you should be familiar with all these. It could be represented as P of E bar. It may be represented as P of E dash, like this, or it may be represented like P of E superscript C, like that. Various ways the notation can come. So please be aware of this. So what is the mathematical way that you are going to interpret this complement of an event? So suppose I say probability that a particular event E happens. I'm saying that it is P of E. Then P of E bar, that is nothing but 1 minus P of E. So that's what we saw earlier, right? 80% chance that it is going to rain. Then 100 minus 80, I will say there is a 20% chance that it is not going to rain. So basically, P of E complement or P of E bar, it is equal to 1 minus P of E. I can also say that P of E plus P of E bar, that value, it is equal to 1. So please make a note of this also. Okay. We will also consider, suppose I say probability for a particular event, it is equal to 2 by 3. Understand probability that the event it's not going to happen. It will be 1 minus 2 by 3. And that is coming here as 1 by 3. So this calculation, how it is made, kindly make a note of the same. Okay. Now, let's talk about something called as mutually exclusive events. What are they all about? So consider an example here, an experiment here that you are tossing a coin. Okay. So just imagine you're taking a coin. It's an unbiased coin. So you're just tossing it. Now, we know that the possible outcomes when you're tossing it, you're assuming that the coin, it falls flat. The outcomes possible, you're going to see heads or tails. Okay, fine. Now, here we can understand that the happening of heads, it will prevent the happening of tails. Right? If it's heads, definitely you can say it's not going to be tails. In the same way, happening of tails, it will prevent the happening of heads as well. If it's heads, then definitely it's not going to be tails. If it's tails, it's not going to be heads. So these types of events, I call them as mutually exclusive events. So happening of one event, it will suppress the happening of the other event. If that is the scenario, I will say those events, they are mutually exclusive. So in that scenario, suppose I am asking you, if the events are mutually exclusive, what is the probability that you are going to see a heads and tails when you are tossing a coin? I will say that is equal to 0. I am defining the event heads and tails. I'm tossing a coin, heads and tails. Now I'm asking you, what is the probability that you're going to see heads and tails? It's equal to 0. Okay. So if the events A and B I'm considering, they are mutually exclusive. Please be aware P of A and B, that value, it will be equal to 0. Okay. If otherwise, if the events, they are not mutually exclusive, I call those events as independent events. Okay. Now, having said this, it's time for us to talk about addition theorem of probability. Very simple. I'm sure you all remember, you have learned N of A union B. It is equal to N of A plus N of B minus N of A intersection B. Right? In set theory, you all have learned this. When I am considering probability, what you're going to do is all those N values, the N, that letter I have used, you replace it with P. Then you know how it will look. If A and B, they are two events, P of A union B, it is equal to P of A plus P of B minus P of A intersection B. Now here, I want you to look at this P of A intersection B. I have just mentioned that A and B are two events. Okay. So here we need to consider two situations. Case number 1, A and B are mutually exclusive. In that case, please be aware P of A union B, it will be equal to P of A plus P of B. Because if the events A and B are mutually exclusive, please be aware that P of A intersection B, that will be equal to 0. So this is the result that we will be considering when A and B, they are mutually exclusive. Otherwise, that is A and B, they are independent. We have P of A union B, that is equal to P of A plus P of B minus P of A intersection B, which I will write it as minus P of A into P of B. Please note the events are independent. In that case, P of A intersection B, it will be equal to P of A into P of B. So like that, you will be analyzing this mathematically. The questions what you may see, you will be given P of A union B, you will be given P of A, and then you will be asked to find what is P of B. Three elements are there, two will be given, one item will be missing. You may have to calculate that. And in the same way, application of this result, the addition theorem of probability, based on that, you can expect questions. But you should be aware of this result, so kindly make a note of the same. Now the next one, conditional probability. So the events that we have considered so far, they are without reference to other events or any other conditions. You are simply tossing a coin or you are doing an experiment just like that. But very often, we may have to consider certain events which are based on some conditions. It is in relation to the occurrence of other events or other conditions. And that's the time where we talk about conditional probability. I have set some questions using this logic conditional probability. At that time, we will recall these terms. But for the time being, I request you to make a note of two important results here. Probability, I am writing it as A by B like that. You see, I have written it. It is actually written as probability that A given that B has happened. P of A given B. P of A, what is the probability that A happens given that B has happened? That's how this is interpreted. And that is equal to P of A intersection B divided by P of B. Mathematically, this is how the calculation it goes. In the same way, P of B, given that A has happened, it is equal to P of B intersection A divided by P of A. Okay. Now, if this A and B, they are independent, they are not bounded by any condition or any other aspects. In that case, please be aware, P of A given B, it will be equal to P of A itself. If that's the case, I can see that A and B, they are said to be independent. Okay. Now, in the same way, you have to use these equations and conditions, analyze the question carefully, and then proceed answering them. Okay. Now, let's talk about something called as an expected value, what it is all about. See, this expected value, this concept, it has got something to do with gambling, something to do with the gambling events that are happening in casinos and all. So just for your understanding, how the calculations that you need to make, I'm explaining this concept. Okay. So I'm going to present in front of you a small scenario. Consider there's a person by name Eric. This guy, he goes to a casino where there he is very much fond of one particular game. So there is a game there. That guy, Eric, he is very much addicted to play that game. What is that game all about? I'm explaining. In that casino, this game that Eric, he is too much addicted to play, he just need to roll a dice. So when he is rolling a dice, understand it's a cubical dice. It's a fair, unbiased dice. So the possible outcomes are 1 or a 2 or a 3 or a 4 or a 5 or a 6. Okay, these are the possible outcomes. Now, after rolling this dice, if the dice, it shows a composite number, then understand Eric wins rupees 15. Okay? If the dice, it shows a prime number, Understand, Eric loses rupees 30. Now, the question, it is framed in this way. If Eric, he plays this game indefinitely, okay, he kept on playing this game because this guy is addicted to this game, right? So if he keeps playing this game indefinitely, how much Eric wins or Eric loses? That's the question. So how to proceed? So what I am going to consider here is, I will consider what's the probability that this guy, he is going to see a composite number. Okay, I can say the total number of outcome, it is equal to 6. If he ends up seeing the number 4, or if he ends up seeing the number 6, okay, then understand the event that he sees the composite number, the condition it is satisfied, right? So favorable outcome 2 out of total number of outcome 6. Please be aware that that number, it is neither prime nor composite. Okay. So probability that he ends up seeing a composite number, it's equal to 2 by 6. I will say that is equal to 1 by 3. In the same way, let's find out what is the probability that he ends up seeing a prime number. The total number of outcome, it is 6. He ends up seeing the number 2, the number 3, or the number 5. Total number of favorable outcome, it's 3. So 3 by 6. So the probability for a prime number, it is equal to 1 by 2. So I have found out what's the probability that he is going to roll a composite number. What's the probability that he is going to roll a prime number? Those values are ready in front of me. So in this manner, in order to calculate this expected value, in order to find out if this guy is playing this game indefinitely, how much he wins or loses, the question comes this way. Step number 1, you find out the individual probabilities of all the events that are mentioned. Now let's do the calculation. The expected value, probability that he rolls a composite number, it is 1 by 3. And what is the monetary value associated with this? You can see that if he is rolling a composite number, he wins rupees 50. So I will consider the monetary value associated with this as 15, and I'm just closing it. In the same way, what's the probability that he rolls a prime number that's equal to 1 by 2? What's the monetary value associated with this prime number? He loses rupees 30. So I'm just considering the 30 over here. Okay. So I'm just writing it like this. So what I am doing is, first I calculated what's the individual probability. Then that probability value, I'm multiplying it with the monetary value attached to that scenario. So 1 by 3 into 50, 1 by 2 into 30. Now I'm going to merge them together. Winning, I'm considering it to be positive. So I'm putting a plus symbol there. Losing 30 rupees, right? He loses 30. That's what it said. Losing, it's negative. So I'm putting a minus symbol here. So net, what is going to happen when I'm doing this calculation? It will be coming as 1 by 3 into 50 minus 1 by 2 into 30. It comes like this. What is 1 by 3 into 15? That's equal to 5. What is 1 by 2 into 30? That is equal to 15. Right? So 5 minus 15, when I consider, I can say that results in minus 10. What does this actually mean? It means that if Eric is playing this game indefinitely, on an average per game, Eric is losing 10 rupees. I repeat, on an average, okay, per game. Okay, Eric loses rupees 10. Okay, so whatever that money Eric is losing, the other way around, if you think, you can consider that for every game, the people who are running the casino, for them, they actually gain rupees 10 per game. Got it? So that's how the calculation actually works. So, in a nutshell, I hope that you have taken down these notes, these points. So, in a nutshell, I will say the expected value, it is nothing but the summation of you take the probability, multiply that with the monetary value associated with that event. Like that, you take the summation. If it's winning, take it as positive. If it's losing, take that number as negative. All put them together, and then you find out what is that final number that you are getting, just like what you saw. Okay, so the question can be worded like, what is the expected value of this game? If Eric plays this game indefinitely, how much he wins or loses? Okay, in the same way, like I asked you earlier, what is the average return or average money that Eric gets or Eric loses if he's playing this game indefinitely? Like the different ways the question can be asked, can be framed, the words can be framed. So be careful when you are reading the question. But end of the day, expected value, this is the formula that you have to use. Okay, so dear students, I have explained to you all clearly that the basic concepts, the terminologies and all. I hope that you all have taken notes while you are watching this video. So I request all of you to apply the same, the concepts that we have discussed while you are solving the questions from the handouts. Okay. So wish you good luck. Make sure that you are practicing well every time. Thanks for watching. Take care.